Good day! This will be the final research presentation of Stanthel Fernando Maria Guerrero Group 9 to the research study entitled Musa Acuminata and Balbisiana Saba Banana Fiber as an Acoustic Sound Absorbing Panel. Good day! I am Mariel Estropia, and together with me are my group mates Gabrielle Narvaez, who is to discuss the statement of the problem to related scientific studies. That is simply about the problems that we are aiming to get an answer. How sound absorption of Musa acuminata and Balbisiana fiber can affect pitch frequency, the effects of Musa acuminata and Balbisiana fiber in sound transmission, and how reliable and efficient the Musa acuminata and Balbisiana fiber is. The second one is the research hypothesis. The null hypothesis that states that there is no significant effect of using Musa acuminata and Balbisiana fiber as an acoustic sound absorbing panel. That has been rejected. Next is the alternative hypothesis, that is, the accepted hypothesis for the study that states that there is a significant effect of using Musa acuminata and Balbisiana fiber as an acoustic sound absorbing panel. The third one is the significance of the study to the parents, students, community members, and future researchers. The last one to be discussed by Mr. Gabrielle Narvaez is the list of titles of related scientific studies, which is the analysis of soundproof property of banana fabric. Next is banana Musa balbisiana trunk as sound absorbent and thermal insulator ceiling, banana fiber sound insulation, and the last one is acoustic sound absorption of natural fiber composites. The next presenter is Samuel Brillante, who will be discussing the methods and results, the research process, the materials, and equipment that was used, the research experimentation, the data tallying, and the data treatment. Also, Samuel Brillante will be discussing the results and discussion, and our Sejan Catipan, who will go into discuss the recommendations, the suggestions based on our findings for the future researchers who are planning to explore the same topic. Those are the highlights or the important parts and details of our experimental research entitled Musa acuminata and Balbisiana Saba Banana Fiber as an acoustic sound absorbing panel, and the suggestions of researchers to further understand the significant effects of using Musa acuminata and Balbisiana fiber as an acoustic sound absorbing panel. In this presentation, we will going to talk about first is the research objectives. The researchers' objectives is to prove that Musa acuminata and Balbisiana Saba banana fiber can be an acoustic sound absorbing panel, to determine if the Saba banana fiber can affect the sound transmission, and to know if Musa acuminata and Balbisiana fiber can help to reduce the pitch and frequency of a sound, and to know if this can be a great tool or a solution to the problem, which is noise pollution. That is also one of the biggest problem of the country.
For the statement of the problem, specifically, this study shall seek answers to the following questions. What are the effects of Musa acuminata and Balbisiana as an acoustic sound absorbing panels in terms of pitch and frequency? And what are the effects of Musa acuminata and Balbisiana fiber in sound transmission of sound waves from producer to receiver? And how reliable and efficient Musa acuminata and Balbisiana is. Research hypothesis. These statements are the expected outcomes of the proposed research study. Null hypothesis. There is no significant effects of using Musa acuminata and Balbisiana fiber as an acoustic sound absorbing panel. For the alternative hypothesis, there is significant effects of using Musa acuminata and Balbisiana fiber as an acoustic sound absorbing panel. This study is conducted in order to determine the effects of using Musa acuminata and Balbisiana fiber as an acoustic sound absorbing panel and how it will be beneficial for various sectors such as the students, the parents, the community members, and for the future researchers. This part of the research will present previous scientific studies that were relevant to the current study. First is the analysis of soundproof property of banana fabric. Next is banana trunk as sound absorbent and thermal insulator sealing, and banana fiber sound insulation, and acoustic absorption of natural fiber composites.
My name is Samuel Antonio Brillante, and for our research methodology, our research study is through experimental research. This research design allowed us to manipulate independent variables in our control groups that help us researchers to obtain needed information to test our formulated hypotheses under the study. Our study was treated with leptal test, and research study followed systematic research processes, including gathering of materials and equipment, including Musa, Acuminata, and Balbisiana fiber, elastic, transparent beading cords, device with a tuner, cutting blades, and tape measure, and proceed to research experimentation. Our research experimentation has two groups, which are the experimental and control groups, and the distinction between those groups is that in experimental group there's no any presence of improvised panel, while in control group there's a panel in between sound producer and sound receiver. And the next step is the data tallying and data treatment, which are evaluated and calculated and measured by the researchers themselves. And our research experimentation has three stages: pre-experimentation, during experimentation, and post-experimentation. Pre-experimentation, or before experimentation, we researchers first gather the needed materials and equipment, including Musa Acuminata fiber, and we just use cutting blades to strip the banana fiber and pseudo stem. And during our research experimentation, like what I said, we have two different groups: the controlled and experimental groups. And in experimental groups, and in experimental and control groups, they are actually treated fairly and equally. It just happened that in control groups, there's a presence of panel or improvised panel in between sound receiver and sound producer, while in experimental group, there's no any presence of improvised panel in between sound producer and sound receiver. And I just want to clarify that in both groups there are four setups: setup A, setup B, setup C, and setup D. In setup A, there's a 2 centimeters thickness of the panel in control groups, and setup B, there's another increment of 2 centimeters in thickness of the panel, which is total of 4 centimeters in thickness of panel with 11 inches by 7.5 inches in length and width. And setup C has a 6 centimeters thickness of the panel, while in setup D there's 8 centimeters thickness of the panel. And in each setup in both groups, the sound receiver and sound producer were placed in each side of the panel with 2 centimeters distance away from the center of the panel and without the panel. In experimental groups, there's no any panel. So in the next part of the research, we will tackle about the results and discussion. But post experimentation, we just stack up and keep the Musa Acuminata fiber improvised panel and proceed to the data tallying and data treatment, which to be discussed in the next stage. The results and discussion of our research study. I just wanna clarify things first, that the sound used in the study was the sound effects of shotgun found and played in Facebook in YouTube. Though we should respect the idea that the actual sound of shotgun was different from the sound effects offered in YouTube. And proceed to our first table, an experimental group versus control group. And in each group there are 4 setups, and because in experimental group there is no presence of tangible panel, we just increment the value of the panel to the distance gap between sound receiver and sound producer. We just assume that there's an imaginary panel between sound producer and sound receiver. And let's say that the distance gap between sound receiver and sound producer was just 4 centimeters, and we just add up the 2 centimeters thickness orientation of the panel to the distance gap to measure the sound transmission. And this may sound consistent, but in experimental group, there is a consistency in terms of frequency and pitch in sound being transmitted. From setup A to setup D, there's a consistent of 1959.3 Hz with pitch of P sub 6, and on the other hand, in control group, because there's a presence of tangible improvised Musa Acuminata and Balbisiana fiber as a panel, we just expected that there's a variation in terms of pitch and frequency. From setup A with 2 centimeters thickness orientation of the funnel, we had tallied that the frequency was 1944.9 Hz with pitch of B sub 6. In setup B with per centimeter thickness orientation of the panel, we had tallied that the frequency was 1878.2 Hz with pitch of A sharp sub 6. In setup C, we had tallied that the frequency was 1788.3 Hz with pitch of A sub 6. In setup D with 8 centimeters thickness of the panel, we had calculated and tallied that the Hertz, the frequency transmitted was 1700.5 Hz with pitch of G sharp sub 5. And proceed to our calculation for mean difference. We researchers have computed the mean difference, and the formula for this is experimental group data minus control group data. And in setup A, there's a computed mean difference of negative 14.4. In setup B, there's a computed negative 81.1. In setup C, there's a computed 171. In setup D, there's a computed negative 258.8 mean difference. And for the total, we just calculated the total average mean difference between 4 groups, and the calculated mean average between 4 groups is negative 131.325. And this computation was manually computed by the researchers themselves, and the computed standard deviation was 106.5. And to test the formulated hypothesis, we researchers have formulated that and assume that null hypothesis must be mean difference greater than equal to 0 to be accepted. And alternative hypothesis, on the other hand, must be mean difference less than 0 to be accepted. And the significance level used in this study was 5% or 0.05. And the number degrees of freedom in the study was 3, because 4 minus 1 is 3, that's the degree of freedom. And overall, the computed t-value was negative 2.47, and it is located in the rejection region from the t-value distribution. Therefore, our null hypothesis was rejected, and alternative hypothesis, on the other hand, was the one to be accepted. And null hypothesis states that there is a significant effects of using Musa Acuminata and Balbisiana fiber as an acoustic sound absorbing panel. Null hypothesis was rejected, and alternative hypothesis that states that there is a significant effects of using Musa Acuminata and Balbisiana fiber as an acoustic sound absorbing panel was the one to be accepted. Overall, the findings of the study, we can infer that and draw conclusion that Musa Acuminata and Balbisiana fiber has a significant effect as a sound acoustic sound absorbing panel that affects this transmission of sound frequency and pitch by absorbing and insulating sounds. And we can also infer that Increasing thickness of Musa Acuminata and Balbisiana fiber as an improvised absorbing panel affects the sound transmission. As there is an increase in thickness of the funnel by 2 centimeters, we can infer that the pitch of the sound goes one step down lower and absorbed frequencies goes and becomes higher. And moreover, we can totally infer that Musa Acuminata and Balbisiana fiber as an acoustic sound absorbing panel is good for sound insulation and sound absorption. Thank you.
Recommendation. The following statements are the recommendations of researchers to furtherly understand the significance of effects of using Musa Acuminata and Balbisiana fiber as an acoustic sound absorbing panel. Researchers recommend to practice the conversion of biodegradable materials to useful and handy materials to improve the overall status of society. Researchers recommend to future researchers to add manipulation in control groups to furtherly assess the effects of Musa Acuminata and Balbisiana fiber as an acoustic sound absorbing panel. To innovate the products out of banana fibers, researchers recommend to reduce the decomposition rate of those banana fibers. Researchers recommend the testing of Musa Acuminata and Balbisiana fiber with different moistures as an acoustic sound absorbing panel to widen the knowledge about this product.